In this section 3.4 example 2, already they built a quadratic model for us, and we are going to get some information from the function given to us. But let me read the problem one more time so that you'll understand what is given to us. It says a projectile is fired from a cliff 200 feet above the water at an angle of inclination 45 degree to the horizontal. With a muzzle velocity of 50 feet per second, the height of the projectile is given to us. So actually with this information, whatever I read, this function has already been built for us. So we didn't have to do anything to build the function in this problem. The only thing we have to do here is answer a few questions with this given function. So as I've told you before, remember we talked about the dependent and the independent variable. So let me put here, this is the dependent variable, which is the height. Height is my dependent variable, and x is actually the horizontal distance of the projectile. Distance x is my independent variable. Can you imagine that's the base of the cliff? Okay, so we all know that if you throw something in the air, it's going to take a parabolic path, but because it's already 200 feet high, the path of this projectile is going to be something like that. Okay, that's where it's going to come and hit the ground. Okay, so the first question is asking how far from the base of the cliff is the height of the projectile maximum. So how far from the base of the cliff is the height of the projectile maximum? Okay, so it's asking for what is the x distance for which the projectile height is the maximum. In this example, we will do example 2 of section 3.4 with the function given to us, which is h of x equals negative 32x squared over 50x squared plus x plus 200. We are going to get some information from this function. Now, as we talked before, the independent variable is x, which is the horizontal distance of the projectile from the base of the cliff, and the dependent variable is the height, h of x of the projectile. Okay, so we all know that if you throw something in the air, it's going to go in a parabolic path and hit the ground. Okay, so the first part of the question is asking how far from the base of the cliff is the height of the projectile is maximum. And then B is asking what is the maximum height of the projectile. So technically it's asking for the vertex of the parabola. And when you look up here, the given function is a parabolic function. Let me rewrite it. So negative 32 over 50 squared is my A value, x squared, plus B value is 1 because it's x, plus C is 200. So I am going to use the same formulas that we used in 3.3 to find the vertex. A is negative 32 over 50 squared, B is 1, and C is 200. To find A, what I need is the h value, which is the x coordinate of the vertex, negative b over 2a, negative 1 over 2 times negative 32 over 50 squared. I think you can simplify this and give me the answer here. And since the distance is measured in feet, whatever you get will be that many feet. That is the x distance. Okay, So this answer, I want you to put in your calculator and put that in there. So B is asking for find the maximum height of the projectile. So whatever answer you get there, take it back into the function, plug it in here, and wherever you have x, you are going to put that value in and simplify it, and whatever the answer you get will be the height of the projectile, and that is going to be in feet too. Okay, so you will be doing this simplification, and if you want to check the answer, ask during class. Okay, there's one more thing to talk about, the last section of this problem, where it is asking us how far from the base of the cliff will the projectile strike the water. Because so if you think of the path of the projectile, you're already standing at a 200 feet height, and then you would be throwing a projectile. So the projectile is going to take a parabolic path and it's going to come and hit the ground. So when it hits the ground here, the height of the projectile is 0. So we need to know what this distance is. So, or in other words, mathematically it is the one of the x-intercepts, that's what we are looking for. So we know in order to find the x-intercept or the height as 0, we can put 0 is equal to negative 32x squared over 50 squared plus x plus 200. And then if you solve this quadratic equation, you will be getting two x values, and one of the x value must be 0 because that's where the base starts, and the other x value will be the 1. That is the answer to this problem. I'm leaving this here, and if you have any questions, please ask. Okay, this is just solving a quadratic equation. And again, let me rewrite it one more time. So my a value is actually negative 32 over 50 squared. It's like ax squared plus bx plus c equal to 0. Okay, solve this quadratic equation and get me the two x values, and if you have questions we can talk in class.